There we go. Audio's here. I apologize. Good morning to you guys. I apologize to all of you guys at home with the audio. Woo! Anyway, let's go back here. Let's kind of paraphrase here if you guys didn't get any audio here. We're solving trig equations this morning. And we got 2 cosine theta minus 1 and 0 as the first example. We want to answer where is theta's, what is the angle theta? So we're going to start by restricting our domain here from 0 to 2 pi. That's the quadrant 0 to 360 degrees. So let's get this up here. All right. So now you got so what you end up doing is you want to solve for that cosine theta. And that's what we did here. So you get cosine theta here is 1/2. So just to kind of reiterate. Now, cosine's nice and positive, which is great because we can create our right triangle. And we always find here that we have this special triangle here. So remember, there's only 2 special triangles that you need to know. The 45, 45, 90, and the what? 60, 60, or I should say 30, 60, 90. This is the 30, 60, 90. Okay, so here's my 60 degrees. This is bisected. This is the 30 degrees, and then this is the angle, the 90-degree angle. So cosine theta here being 1/2 means that the angle, the right triangle there, that theta has to be 60 degrees, or pi over 3 in terms of radians. So what we did was we went back and said, hey, but we restricted our domain. You say, yeah, we have to restrict the domain from 0 to what? 360, because we're trying to look at all solutions within that restriction. Because there's infinitely many solutions if we didn't do that. Right? So you say, what do you mean we restricted the domain? Well, if I go to Desmos, right, and I said, hey, let's look at cosine again, but let's look at cosine without a restriction. And then let's look where y equals 1/2. What I'm saying is that there's infinitely many solutions here. Here's one, here's another. Okay. Negative pi over 3, positive pi over 3. Here's another. 5 pi over 3, 7 pi over 3. So we restricted the domain here for cosine to be between 0 and 2 pi. And that's just one revolution of the circle. So if I go back and I say, okay, here's my 0 less than or x less than or equal to 2 what? Pi for you guys. This is how I restricted the domain. And we're going to see why here. Why is it that there's 2 solutions? Right? Pi over 3 and 5 pi over 3 is where you intersect that curve. These are the solutions. So why is there 2 solutions? Well, we restricted the domain from 0 to 2 pi. And when you do that, here, we always remember that the positive answer is your reference angle information. This is what we've always been going to. So theta being 60 is the reference. Remember, quadrant 4 cosine is also positive. So if I use that reference angle in purple, which is 60 degrees here, okay, if I use that here, that's the reference angle. Remember the shortest distance along the unit circle to the terminal point, right? And the x-axis, the shortest distance here. That was our reference angle. This information we're using again. We got to use that reference angle. So quadrant 4 is the other location where cosine's positive, and that's what that C means right here. Right? That's why we have that C. So taking 360 minus the reference will give you the second solution here. Now, that's kind of where we left off, I guess. But we got to do some arithmetic. You say, what is this going to be? Well, this is 6 pi. Remember we did all that arithmetic over 3 minus pi over 3. And what does that give you? 5 pi over 3. So your solutions are going to be the following. We got the first solution here. It's pi over 3. And the second solution is going to be what? 5 pi over 3. So this is why Desmos, and you say, what does Desmos have this here? Well, they restricted the domain from 0 to 2 pi. It's not about finding an inverse function. It's not inverse function. This is really saying, can you give me solutions that are really in quadrant 1, 2, 3, and 4? And that's where we're at. So there's a little bit difference in terms of the restrictions of the domain. And that's the deal here. Okay, now I want you guys to note something here because this is something that's really important as well. Note. If they were to say to you, they give you 2 cosine theta now, plus 1 equals 0 here. Right? And you had to solve this trig equation. Where is it? Solve for cosine theta. Right? You get 2 cosine theta by subtracting 1 is negative 1. You divide both sides by 2, what do you get? Cosine theta is negative what? 1/2. Now, the reason I bring up this problem is because it's related to the one we just did here. Okay? It's very much related. So that's why I'm calling it a note here. You say, how is this related? Because remember, if we were to try to solve for cosine, I mean for theta, we want to know what theta is. What's the angle? Do you guys know what you have to do now, right? You're going to have to go now to the what? To that reference angle being positive 1/2. Because we need our point of reference. Okay, we need to know where this angle is 1/2. And so where is that angle 1/2? It's, again, what you're seeing in that past example. So the reference angle is the quadrant 1 angle. This is the geometry portion. Quadrant 1 is what we're looking for, the positive angle. And as you guys can see, we already found that. I don't want to move everything. We already found that. Let's get this here. Okay, so we know that cosine of the reference is positive, but that's not what they gave us. They gave us a negative angle. So again, you're going to have to bring in our all students take calculus. I'm going to bring the other one in. All right, we're going to bring the other one in. Okay, so you say, but Mr. Judge, and let's get the right colors. Right, how does that work if we're trying to solve the equation where cosine theta is actually what? Negative 1/2. How does that work? Well, what quadrant is cosine negative? Do you guys know? Yeah, quadrant 2 and quadrant 3, our cosine is what? Negative. So what that means is, ladies and gentlemen, I have an angle I have to find in these two quadrants. Let me do this here. This is theta. And this is a second angle theta. But how do I use that reference? Do you guys remember? This is the key. The reference angle was along that unit circle. Right? There's a terminal point here. It's the shortest distance to the x-axis. This is 60 degrees. Do you guys remember that? So along the unit circle, you have that terminal point to the x-axis. This is how I use that reference angle. I have to use the reference, 60 degrees. What does it mean about theta then? That first solution. We're going to say there's two here. So theta 1, how do we get theta 1? Do you guys remember? Maybe I should put it over here. How do I get that? For quadrant 2, how do we get that? Do you guys remember? It's 180 minus the reference angle, 60. Is that true? Do you guys remember this? Let me draw a ray for you. If you said, I don't remember this stuff. Well, yeah. Stop and think about this, right? Why is it what it is? This is 180. We have to back up the reference, subtract 60. I'm going to do that again. This is 180. We're going to back up 60. Try it again. This is 180. We're going to back up 60. What does that give you? 180 minus 60 gives you what? 120. So what if this was, ladies and gentlemen, what if you have pi minus, what is this, pi over 3? Is that right? Radian measure. Do your arithmetic. Make this 3 pi over 3. We've seen that. And now we get what? 2 pi over 3. And there it is. That's your first angle. How do we get the quadrant 3 solution? Do you guys know how we get quadrant 3? Well, it's the same way. I'm going to use reference information, but this time I'm going to say to you, let's do this. Here's your 60 degrees. So how do we get the angle over here? Do you guys know? How do we do it? How do we do it now? You're going to try to get this angle here. This is your theta 2, second angle. So for quadrant 3, how do you get that? Do you guys know? Here's what you do. You take the 180 and now you add what? The reference. Is that true? You take 180 plus your reference. So this will give me the second angle, 180 degrees plus the reference of 60 degrees. And what does that give you for the second angle? That gives you 240 degrees. So my second solution here, ladies and gentlemen, if it's radians, is pi plus pi over 3. And so do your arithmetic, right? 3 over 3. I want to get red. Right? So you get 3 over 3. What's that going to give you? 4 pi over 3. So these are going to be your solutions here. 240 or 4 pi over 3. 120 or 2 pi over 3. But I want you guys to know these formulas here. Okay? That a quadrant 2 solution here And we'll do this here. We'll summarize this here for you guys. Okay, I'm going to summarize it for you, but I just want to go back to Desmos briefly and now say what happens when this here is a negative 1/2. Okay, and that's what we found here. These are the solutions. So you have cosine being negative 1/2, you get 2 pi over 3 and 4 pi over 3. Okay, those are the locations on your curve. All right, you guys okay with that? So that's verifying what we just did. However, let me give you guys the summary that we're going to be using here. Not a template. Let's go cancel. Let's give you guys the summary here. We're going to be using this. Okay, I want you guys to know something here. In quadrant 1, give you a nice summary here. When you have to find a quadrant 1 angle for a solution, okay, the reference angle is the angle, quadrant 1. Quadrant 2, you say, Mr. Judge, I have to find an angle, and this is that theta value. Let's say you have a quadrant 2 situation. Trying to find a solution in quadrant 2. Okay? Trying to find theta. What's the equation? Theta is what? Pi minus the what? Reference. If your angle, and it might be just better to write the theta up here, okay? Because all of these circles and lines, you know. So our theta here for quadrant 3 will be pi what? Plus the reference. Okay? This is the format you guys are going to use here to get your angle theta. Theta is a solution. Here's your reference. And then finally at the end, you get theta here. You say, what if my angle is a quadrant 4 angle? Well, that's going to be 2 pi minus the what? Reference. So this is how we're going to use the all students take calculus for various angles in quadrants 1, 2, 3, and 4, which is why we restrict our domain to begin with from 0 to what? 360 or 0 to 2 pi. All right, so I just want to let you guys know that that's kind of how you do this here. You know, this is solving trig equations. So let's give you guys another example here. I'll let you guys copy that down, give you another example. And say, what if they gave us here tangent theta equals maybe just the square root of 3. Or how about this? No, tangent theta will be positive 1. And yes, we're going to restrict the domain from 0 to 2 pi. Okay, we want to know what theta is, right? Solve for theta. So the nice thing about this question here, right, what's really nice, and I want you guys to pay attention to this. This is an important detail. 1 is positive. Is that right? So that's good. Because, anybody know why that's a good thing? Because when I say to you, go to your reference angle here, information, 1 over 1. The hypotenuse is the square root of 2. What special triangle is this? Yeah. So you have another special triangle, ladies and gentlemen. There's a special triangle here. What's that triangle going to be? Isn't this the 45 degree triangle, special triangle? 45, 45, 90? Isn't that pi over 4? Okay. Pi over 4, you guys with me on that? It's 45 degrees. Now, you might say, well, didn't you just tell me here, 45 degrees is a quadrant 1 angle? It is. That's the first angle we got, 45-degree angle. But isn't tangent also positive somewhere else? Where is tangent positive if you say all students take calculus? What quadrant is tangent also positive? Quadrant what? You're looking at it, ladies and gentlemen. This is why you memorize all students take calculus. This is why we went over those terminal points and circular functions. Where is tangent positive? Quadrant 1 and what other quadrant? Is it quadrant 2 or quadrant 3? Isn't quadrant 3 tangent positive in quadrant 3 as well? Okay, so then how do we get our answer? It's pi plus what? Pi over 4. So the second solution is going to be here. You say, oh, that's going to be pi plus pi over 4. Well, do some arithmetic. And that 4 over 4. So my second solution is going to be 4 pi over 4 plus pi over 4 gives me what? 5 pi over 4. So, ladies and gentlemen, here we go. There's 2 solutions here. Okay, what was the first one? Just simply pi over 4. There's your first one. Now, let's verify this here in Desmos because, I'm going to give you guys here in Desmos again. You say, Mr. Judge, generally speaking, there's infinitely many solutions, right? Generally speaking. Say this is when y also is 1, just so you guys know. You cross there at infinitely many places, but this is why we restrict the domain for tangent. We restrict it in such a way that it goes through quadrants 1, 2, 3, and 4 from 0 to 2 pi. Okay? So here's tangent restricted from 0 to 2 pi. Notice these points of intersection here. Pi over 4 and 5 pi over 4. So that's where tangent equals 1 for the restricted domain. Now, what I'm going to change this on you guys to see if you guys understand reference, because that's an important thing. I'm going to go to -1. Okay? So you're going to say, Mr. Judge, what if that's -1? Well, guess what? We can do that too. We're going to find that it's 3 pi over 4 and 7 pi over 4. And you might say, why? Right? Why is that? Well, what if we did that? I'm going to put it as a note. Right? So, for example, they said, can you solve this equation for theta? I know I've been giving theta, and it equals -1. And I'll say, okay, be careful because why? You have what again? You got that -1. You're going to have to go to the what? The reference information. So you say, what's tangent of the reference? This is always a positive angle. You already got that already in the last example. That was pi over 4. Okay, we did this already in the last one. So how does it work now? Well, tangent is negative in what quadrants? Do you guys know? Where's tangent negative? I'm going to erase this here. Tangent is negative in quadrants. I'm going to get my red. Quadrants what? 2 and 4. Is that true? Okay, what was the reference angle? In purple? Wasn't that pi over 4? Put pi over 4 over here. So what that means is my first solution will be pi minus pi over 4. Do you guys see that right there? The second solution will be 2 pi minus what? Pi over 4. Because tangent is negative in quadrant 2 and 4. Okay, so do your arithmetic. And what do you guys find? What's the first solution going to be? What's 4 pi minus pi? Isn't that 3 pi over 4? So here's my first solution, 3 pi over 4. The second solution is over here. What's the second solution? Right? You're going to do this multiplied by 4 over 4. So that's 8 pi minus 1 pi, which gives you what? 7 pi over 4. So here's your solutions, 3 pi over 4 and 7 pi over 4. So ladies and gentlemen, this here, this picture, is what you definitely want to have in your what? In your notes. You always get the reference angle, and then you use this picture. Well, anyway. So we have you guys try a few? I'm going to have you guys try one here. Oopsie. I'm trying to look for one that, come on. Try this out. We'll see what you guys get here, okay? We're going to give you guys some time in the clock here. See what you get. Back to the browser here. Here's kind of the thing. You guys are not in 262 yet. You will be. You're in 241. If I go back now to worksheets and videos, or just really, I should say videos. I went through solving, look at this, solving trig equations. And I have a bunch of other examples. I'm going to put this in the comment section here. Okay. Audio should be good. Can you guys hear me? Our audio should be there. You guys hear me out there? You guys at home with the bonbons? You guys hear me here? Hopefully. Microphone on my end says it's good to go. I did pause it in the beginning, but okay, well, here's the deal. If you want extra examples, click here. Okay, this is solving trigonometric equation. Let me double check. Something's not right. Anyway, I need to get to single angle. This is too close together. I have to fix this when I get home. Okay, I want to go to the single angle questions, and it looks like it's overlapped. Yeah, these are some of the ones where you have some algebra. These are the algebra versions here. So I'm going to fix this when I get home so it's not overlapping and you can access single angle. But as you guys can see, there's all these videos there that are going to be there for you guys. And I'll put that even in Canvas for you. Okay, I'll put it in Canvas. So I do have some of the extra resources for you guys there. in the browser. Yes, I'm going to fix these links. When I get home, I got to space it out. I got to figure out that part. So anyway, you have additional examples there for you. You're going to have a whole bunch of examples if you want to see that. But I do want to say you might want to get started on what? Where's the Canvas information? This is 7.5, ladies and gentlemen. So I'm going to say you might want to get started on that 7.5 section. Okay, this is solving trig equations right here. The 1 to 39 odd. Now, we're not done with this, but you can try to get started with some. Okay. But it's an important topic because you solve trig equations in various math courses and science courses. So you guys want to look at that, okay? Anyway, have a great day. Take care. Stay safe. And we'll see you guys tomorrow.